So, hello everyone, and welcome to our talk. I hope you had a good lunch and you are not too tired. Our talk is this title. I'm not gonna read it because it's too long, but we promise we will go through all the buzzwords in it. So, a couple of words about myself. I currently work on a Kedify.io, which is a small startup from San Francisco, but we are mostly guys from Brno. Previously, I worked from Giant Swarm, APSA, and Red Hat, and Oracle. But I don't want to talk about it. And I'm also that kind of jerk that has a custom license plate. This is parking outside, so blame me. And stage is yours.
Thank you. Hi everyone, I'm Yury from Abound. Abound, you might heard about us as the creators of Crossplane project. But today we're going to speak about another project that I created a while ago, and actually we worked together in APSA with Irka, and that's where we worked on a global load balancing stuff together. So let's kick it off. So where we actually started, and like 5 years ago, with the problem that standard GSLB global server load balancing solutions were mostly proprietary, not flexible, very locked in into specific vendors, and it was pretty much hard to run it with Kubernetes on top of Kubernetes, and like it's not very integratable, let's say. And to solve this problem, we started to create something Kubernetes native. And that's where our project, KGB, Kubernetes Global Balancers, comes into play. It was created roughly 5 years ago. The main properties is like it's open source by design, it's cloud native, it's designed to be run on top of Kubernetes, and with Kubernetes, it's totally vendor neutral. There is no vendor behind it. It's a CNCF sandbox project as of now. It's as multi-cloud and cloud agnostic as possible. You can run it anywhere. It's on-prem, cloud, local laptop, whatever, everything works. And it's naturally API driven as it runs on top of Kubernetes. So we basically injecting GSLB capability right into Kubernetes ecosystem with this project. So a key kind of features and functionalities that you can achieve with a Kubernetes Global Balancer is that you can handle high impact regional failures. It's kind of default mode. When you're running multiple clusters, you can do some failovers, steering traffic from non-healthy to healthy clusters, and everything is based on a battle-tested DNS protocol, right? So it's kind of smart DNS-based traffic management. Everything is abstracted with a simple custom resource on Kubernetes. There is no management cluster, meaning like there is no something like a state or control cluster. We spread KGB controllers across the workload clusters, and inherently we do not have any single point of failure. So it's very reliable by design. And we support quite a good set of global load balancing strategies. A little bit of history. I already mentioned that we created it back in APSA to actually solve this GSLB challenge. The main need of the bank and APSA, if you don't know the organization, it's one of the largest South African financial institutions. And the requirement was that the default mode of deployment of any application in the bank was at least 2 data centers. And so it was inherent need to create a smart traffic solution across the location, across on-prem data centers, and eventually across hybrid mode between on-prem and cloud. And one of the design requirements, like a design decision, was to actually react to the pod health level. So actually like a readiness check. So our solution is aware what is actually happening within the cluster. We are not relying on a standard GSLB solutions like end-to-end HTTP endpoint health check. We are aware of the cluster state from within the application pod. And it was actually designed to replace the proprietary vendor solution within a bank, and we were successful on that mission. And last but not least, it's like an open source for day one. It's not like it was born within a bank and we open sourced it. It actually was developed in a GitHub from the zero. You can find initial commit. It's all there. We started to build a community around it pretty much from the very beginning. Now to the technical pieces. So there is 3 main components that are shipped together with a Kubernetes global balancer. The first one is embedded core DNS. So this core DNS, well-known project, CNCF project, but it's not the one that is in cluster. It's a separate deployment that is shipped together with KGB, and it is designed to serve these dynamically crafted DNS responses according to the requests and the strategy. There is also external DNS that is also a part of the project, and we use it for automated DNS zone delegation. So basically, we are telling some to upstream DNS to some upstream DNS setup to make our core DNS instances authoritative. And this way we create this upstream, like integrating with a wider world. And the main logic, main controller is a KGB controller that glues all the pieces together and makes all the coordinated decisions according to global service load balancing strategies. If you look at this overloaded diagram, so you can find like canonical for KGB reference example. We have 2 clusters that are geographically dispersed, right? So one can be in US, another in Europe, this kind of setup. And KGB controller, as I mentioned, there is no single control cluster. KGB is deployed next to actual workloads, next to actual applications. And within a stars on the left side and symmetrical to the right, you can see these 3 main components. KGB controller itself, core DNS, and external DNS, right? So what happens when some client or like a client service asks for a globally available FQDN, like some global app.example.com. So it asks first upstream DNS, we call it HDNS within a project. Thanks to automatically configured zone delegation, the actual request is going to be steered to a core DNS instances, to one cluster or another one. Important piece that they always will return symmetric, consistent responses. And core DNS is going to read special DNS endpoint custom resource that is getting populated by KGB controller. So the actual responses, what kind of IPs are healthy and where to steer the traffic. And these decisions, the set of IP addresses to return to the DNS request is driven by mainly 3 factors. So GSLB strategy itself, the healthiness of the application. So KGB controller is aware of the pod healthiness status transitively through ingress and associated services. So like if you know, like if a service endpoint array is empty, then we do not have, we have applications pretty much unhealthy bad state. Then in this case, we can fail over the traffic, for example. And the third factor, as clusters should be actually aware of each other's status. Cluster A should be aware of the status of the application on the cluster B and vice versa. And they are syncing this state through the DNS-based special FQDN cross-cluster sync pool, and this way they actually can make this control decision, and they are globally aware of the status, and they can steer the traffic to the proper healthy location. So that's roughly how it works, and you can imagine it's like quite amount of moving parts, but all this relative operational complexity is fully abstracted away by a simple GSLB custom resource. So we have KGB controller reconciles kind GSLB, and we have a pretty limited spec. And the spec is a strategy itself. In this example, it's a failover and a failover strategy configuration as a primary geotag. And we have a resource reference where we can point to standard ingress, and that's how we will resolve transitively the application health status. And as you can imagine, it's totally commoditized GSLB. Any dev teams can just drop in GSLB into their namespace or extend their existing Helm chart, referencing existing ingress, and enable GSLB function for the application without contacting any networking team. So everything is fully automated. And if you focus on the resource ref part, here historically we were supporting only classic ingress. Now with a recent community contribution, we also can integrate with a service mesh, with the Istio virtual service, and this way we can enable GSLB for more advanced mesh-based clusters. Back to the environmental requirements, we basically can run the project on any CNCF conformant Kubernetes cluster, like anything will work, even local kinds or KCD, up to the on-prem cluster, up to any of the managed AKS, GCP, AWS, and we will have a demo today around this cross multi-cloud deployment. And this way you can create like a really complex global load balancing scenarios. And out of the box we are supporting full zone delegation automation with major cloud providers and major players in a DNS ecosystem, plus Tsarev C2136 you can integrate with a classic bind or Windows DNS, so it makes it so flexible. Now to the kind of more future functionality part on a support of different global load balancing strategies. So we support actually 4 of them. Round robin to spread the traffic, weighted round robin, failover, and a GOP. So we can like focus first on the most popular failover one, and it's also mostly like a most straightforward and easy to understand. So assuming we have 3 clusters, KGB is installed on each of them, and we have 3 locations: United States, Europe, and China. By default, if you remember this primary geotech, we pin US as a primary cluster by default, and while the cluster is healthy, traffic is going to be steered to this healthy cluster, nothing special. When the application of this cluster is going to be unhealthy or the whole cluster dies, doesn't matter, then traffic is going to be redirected and steered to the healthy secondary locations. And for our end users, they will not notice any downtime. When you perform the maintenance actions on original primary cluster, the traffic is going to be steered automatically back. So everything is nicely, properly steered in a fully automated manner with a KGB project. Now to the round robin. This is probably second popular strategy. In our case, it's like a roughly randomly but roughly equally steered spread of the load over multiple regions. So like if you have a stateless app, it's very good for this kind of case. Obviously, pretty soon we got a requirement to make a controlled version of it, so we can actually pin the specific percentages and steer some like a little bit more traffic to specific locations and make some like secondary ones. And one of them probably most advanced from a like technical implementation standpoint. It's a multi-region content distribution. It's a GOP strategy where we steering the traffic to the closest location. So according to the geography, clients will get to the closest cluster. And with that in mind, Jirka, please take over.
Thank you, Yury. So let's see that in action. I'm not in here. Yeah, that's my desktop. But I wanted to pin this pop-up. And actually, let's describe first the GeoIP. Sorry. So GeoIP is the most advanced strategy, and it works with a database from MaxMind. It's a format of like sparse. It's optimized for lookup for IPs, and it returns metadata with geolocation, like where the IP is located. But it needs to be updated because IPs are rotated, right? And it works with something called EDNS 0 client subnet option. In human readable explanation, it's a standard or a feature that requires a sender of a client who asks for a DNS resolving to send his own client IP address, and based on this client IP address, it will return the correct response. It also contains certain metadata. We will see that in the demo. And we will use it as a partition key. So here, for instance, there is a country.iso code or continent.code. And it will work in a way that it will first ask this database to give me the continent.code of that IP. And then it will ask for each IPs that it has, the same question, like what's their continent code. And it will return those that matches. Right. And some DNS providers like Cloudflare doesn't support the sending those EDNS 0 client subnet options. So it doesn't work out of the box for them, but for instance, Google does support it. The demo will be quite complex. We'll have three Kubernetes clusters. One will be in North America in GCP, GKE. The other one will be in Europe, in AWS, and the third one will be Azure in Southeast Asia, namely in Singapore. And these are the IPs of the ingresses, or ingress controller that's installed there. So I repeated this IP in here. And let's look to a cluster actually. So we have a free context here. And so this corresponds to our free clusters. And if I inspect the nodes, we will see that this one is Azure, right? There are some Azure specific label. The EKS should be AWS. So yeah, there is a CSI annotation or label for AWS cluster, and the last one is GCP. Yeah, you can see GKE annotations there. These clusters, but I could also use like bare metal cluster and it would work the same way. All these clusters have ingress controllers installed. And these are the ingresses that are present on all of them. Yeah, the AKS is a little bit special because they have ELB, so it needs to be resolved. There is a host name, but if I resolve the host name, there is an IP, and this free corresponds to our free IPs. So these ingresses were created by myself. They were created by KGB controller by creating those GSLB CRDs for us. So these are the objects specific for KGB project, and you can see they are marked with geotag, and this is basically a configuration option of KGB. When you install it to a certain cluster, you name it or label it with some geotag, and then you can reference them in those GSLBs. And all these GSLBs reference just single deployment. For our demo purposes, it's a simple application that responds with some web page. Right, what's also there is the GeoDNS server, which is a internal component of KGB, as Yury has mentioned. And it's also exposed to external world. And this IP is actually used as a last point of DNS resolution using the domain delegation. Right, so let's check the first strategy, which is the GeoIP one. I have an alias that will grab some metadata about my current IP. This is my current IP, and just to convince you that it's so it just send curl to this service. And it's saying like, hey, I'm from Bratislava at the moment, or Nitra, okay. I can do the same to query the local database it's on my laptop, the MaxMind, and it should return the similar data. This way I can debug the stuff because these IPs are rotating, and it's basically similar Slovakia, and you can see here that I was before showing you that continent.code, so this is the JSON path referring to this particular tag here. I could also use country ISO code, and then it will be partitioning the responses on those data, or if it's European Union or not, or something like that. If I resolve one of those host names, for round robin, we assume that all the IPs should be returned same likely. So this is the case, it returns all the ingress IPs. But for GeoIP, I'm actually running a pod on each of those clusters. So here I'm running a pod on EKS EU cluster and asking the same questions, right? Or asking the question for GeoIP. And it will resolve with starting with 3, which is a EU one. But if I do the same question from different location on Earth, which is AKS in this context, in Singapore, it will return different IP address. So that's the idea. This is the ingress controller from the different continent. And the same thing for, or I can actually ask the application itself. I can curl the pod info, and it also has the response configured with GCP geotag. So if I ask the GeoIP endpoint from GCP cluster, it will return the correct response. Yeah, same for all of them. So basically CDN using Kubernetes primitives, right? How is it done? This is the configuration for our core DNS components. And here you can see there is our plugin, or it was forked and advanced and improved. And we are specifying the GeoIP path to our GeoIP table database. And also this is the partition key on which we should basically thread the similar IPs as equal, or from the same location. How this database got there is not perfect, not great, not terrible, but I used init container that downloaded from my repo, because they had an IP from which you can download the updated version, but I didn't want to be surprised by any updates, so I used the fixed one. But you can use persistent volume claim or something like that. Okay, let's check the different strategy. So there's the GeoIP, right? The next one is failover one. So in this strategy, we marked one cluster as a primary one in the GSLB. In our case, it's going to be the GCP one. This configuration needs to be homogeneous on all of clusters. So all of the clusters needs to kind of agree that the GCP one is the primary one. And this is the one responsible for serving the content. But once the application of the primary one will go down, the idea is to go to the next ones. So if I resolve this IP address for the failover, it will go for the US1 ingress controller, right? Also, the curl should return the GCP US. And also, just for the sake of completeness, I will show also the round robin. There are still free IP addresses there, because I want to simulate an outage in one cluster, and this will be shrink to just 2 IPs. So let's simulate the outage. I will just scale the deployment on the primary cluster to 0, but I could also like kill the pod or change the image to something not pullable by the node. So what's done in here? It's what I've done is now the readiness probes for the pod info will not pass, and there will be no endpoints for the service, and GSLB control will recognize that and should switch to the other clusters. So it's still the, yeah. So the first dig was was the GCP one, and the second one switched to the failover ones. This is still the primary one being cached, but yeah. So round robin, they've got just 2 IPs, the working ones. And if I scale the replicas back to 1, it should eventually switch back to the primary one, because the idea is like this is the primary replica that should be offered, but only if it's there. There are caches, so there is a TTL pretty aggressive set to 30 seconds just for the demo, but it's like trade-off, because you don't want to be asking those questions too much because it's costly for Route 53. But now it switched back to the primary one. And it returns with the primary replica. Oh no, now it switched, okay. And also the round robin has now 3 IPs populated in here. Okay, so last demo, which is the simplest one, is the round robin. It's like nothing fancy, it will just switch between those clusters. If you ask the same question from one cluster, it can be the same because of the TTL. So just to help it, I will ask the questions. You can see there's TTL like 7, 5, 3. But I can ask the question using the pods running in those data centers as well. So here I'm basically doing the same curl but running it from 3 different locations that have different cache setup or TTLs for these DNS queries. So we can see that those responses are different in here. It can be the same, like we not promise it's equal, but it is. And the last one is the weighted round robin. It's like hard to demo because there are probabilities involved with hard to measure, right? All right, I think that concludes the demo. Okay.
All right. Thank you so much, Yury. As usual, the most distributed demo in the history of the project. Cool stuff. So currently, just to highlight the current project status, right? So where we are in a CNCF landscape. So we established CNCF sandbox. We are several years there, and now we are already applied for incubating. We are in a good shape, with a good track, in somewhere in the beginning, but already moved in the process. So it will take some time, but we are in process of incubating. That's a good news. We have 6 public adopters. If you are familiar with CNCF adopters MD recommendation, we are collecting names of the companies who can publicly claim that they are using the project in production. So KGB is used obviously in a company where it's originated in APSA, Millennium BCP, largest Portuguese bank, couple of integrators, Brazilian bank, and one of the Portuguese system integrator as well. So basically the folks who are facing this highly available global scale challenge, they are adopting and running the project successfully for a real while, and we are seriously happy about it. It's worth mentioning that we are 2-time security slam finalists, CNCF security slam, so it's a nice kind of competition. Yeah, that's usually connected to one of the KubeCons, and that's where we seriously increased our security posture, and that's where Yury implemented amazing Salsa supply and chain security release pipelines. We're still using them. Everything is signed, and yeah, we are very nice shape in that from that angle. And connected to it, we have a very good metrics on CLO monitor score. It's CLO monitor. It's like a healthiness of the CNCF project. It's objective metrics that are collected from the project status, GitHub repository, release pipelines again, and we are 100 on each of the metric. Which is really nice. And we have a diverse set of maintainers and contributors from multiple companies. So the project in general is in very good shape. And additional slide on the community and growth is this slide is prepared by Bradley, our community manager. Thanks, Bradley. We basically recently just reached an important milestone of a threshold, a recent threshold of 1,000 GitHub stars. We are very happy about this fact. So thanks everybody for support. We have a reasonably active Slack channel and a set of KGB presentations that we collected on our website, and it will be 16 after this talk. 86 contributors. I was actually really surprised that we have so many, like a distinct folks who actually contributed at least like a piece of code into the project. That's amazing. 6 active maintainers, 32 releases, more than 1,500 PRs, and we somewhere around in social medias. We are preparing the new release. Currently it's in RC2 in GitHub, I believe, and we have quite a good set of features that is coming. So it's like a multi-zone support. Historically, KGB controller, like a single controller, could support only single global zone. Now we can actually serve multiple zones with a single controller. There is a new feature called like dynamic geotag. So if you configure KGB, you need to assign geotag to the current cluster or all the neighbor explicitly. Now with the new features, they're actually discovering themselves through a NS record, which is nice dynamic configuration, like in a global manner. Pretty enterprisey feature like a reverse proxy support. Some of the community members asked to override the external IPs in ingress, so we supporting special annotations for that. And there is also advanced resource refs capability that enables easier integration with existing ingress and service meshes. On the roadmap, we have a long-term goal to add the gateway API support, so actually integrate with the newest Kubernetes APIs in the area, and it's still like lagging, as I mentioned to the folks during the launch, like a GCP support is still on the radar, but what it means, like as you've seen, KGB can be run as a controller on a GCP cluster, no issues at all, and it actually can use a Google Cloud DNS. It just automated zone delegation is not fully supported out of the box, but you can configure it by other means, and it will still properly steer the traffic. And yeah, we really want to finalize the NCF incubation process. As I mentioned, we are in the middle of the path there. Just to conclude, if you like what you see, please visit us at the project website, kgb.io. Stars on GitHub, more stars better. And if you're already using it in some capacity, please add yourself to Adopters NB. Just send a PR and we will be happy to merge it. And if you by any chance at KubeCon India, I will be around representing like a KGB project table, project booth there. So thank you so much. And I think we have 5 minutes for questions. Any Slido stuff? Or anything from the audience?
Real life questions.
Yeah? Go shoot.
How do you determine, like, in a failover situation, like, how do you know what is the master?
Yeah, so the master, the primary one is the primary geotech, as this freestyle geotech. You assign to this specific cluster, and the rest, as Irka showed in the demo, we apply a consistent GSLB resource to all of the clusters, so everybody aware that this cluster is actually primary, and that's how failover traffic is going to be steered. Yeah.
This primary geotag is something that's static in the GSLB and is not being switched. Like it needs to be agreed upon that this cluster will be always the primary one, and it means that if it goes down, it will switch to the.
And you have this dotted line which suggests that they're somehow communicating with each other?
Yeah. That's a good stuff. That's important to highlight. Yeah, so in this example, it's just two controllers, and they actually aware of each other's state because they're cross-polling each other. Like, so this GSLB resource is going to ask like how GSLB resource on another cluster feels like right now, and vice versa. And they know they're aware of each other's state, and this way is a failover. Like they aware that this one is unhealthy, this one is healthy, so steers the traffic to the healthy one. So it's like a global states thing.
So you're just calling each other?
Yeah. With a reconciliation loop. You had a question? Yeah.
Special host name for it, like local targets dot and name of the geotag of the cluster, and each of them is resolving all of them periodically and asking questions.
Yeah, so it's a special FQDN, like internal one. Initially, when I was thinking how to implement it, I was thinking like I will do like a KGB style, Kubernetes style API call, but it was like, we didn't require it because DNS, there's no sensitive data flying around, so I just use a standard DNS for that purpose as well. And it's nicely aligned with the overall design.
Nice,
Thank you. Please. Yeah.
Just fall back to the IP address of the resolver?
So how do you, can you like elaborate on this situation?
Yes, you mentioned that some of the DNS resolvers are not putting the EDNS.
EDN 0 for GOP. Yeah.
So how do you decide where to steer the traffic when there is no EDS?
EDN 0 is dependency only for GOP. The rest works without this extension. Yeah.
You just use the IP of the resolver.
Yeah.
It works in a way. The plugin works in a way that if there is no match, like if I, for instance, ask for different continent from Antarctica, right, and I have got only 3 continents covered, it will respond randomly.
Okay.
So EDN 0 is only for client metadata, so to actually figure out where the client is coming from. Yeah, the rest of failover, round robin, weighted round robin work without this DNS 0 extension, just out of the box. Please.
With the resource kind GLSP,
Yeah.
there's the resource ref, and you mentioned that it supports next to the community contribution in the service mesh is there.
Yeah.
Does it also support gateway API? Or
It's on the roadmap, so it's one of the things that I mentioned on like a active roadmap. So currently there is no support for gateway API, but we we are in an implementation phase, let's say. Yeah. You have a use case for Gateway API?
Well, we would like to switch from Ingress to Gateway.
Right. Yeah, so that's why basically we are trying to follow up, yeah.
I don't think in our case we go with KDGP,
Yeah.
because we have F5 and Cloudflare
Yeah, yeah.
and everything.
Mm-hmm.
So we will stay with the Cloudflare approach.
Yeah.
But for some other project,
Yeah, that's cool.
I don't believe I will have a use case for this.
That's nice. Please join Slack, ping us anytime. And Cloudflare, we have a Cloudflare integration, by the way, so where we can configure the zone delegation on Cloudflare side. Yeah. Any other questions? Nope. Oh, yeah, please.
Is there any special consideration for DNSSEC?
You want to take this one?
When I joined the project, I wanted to implement it, but there were like more pressing issues, and it's still open, so not there yet.
All right. So, if no other questions, thank you so much.